I want to talk today about the Fischer esterification reaction. In the Fischer esterification reaction, we start with a carboxylic acid like this benzoic acid, and in the presence of an alcohol like methanol and this acid catalyst, we get this ester plus water. It's also important for us to remember that this reaction is an equilibrium reaction, which is why we use this equilibrium arrow. So let's look at the mechanism of how the Fischer reaction occurs. In the habit of whenever you have an organic reaction with an acid catalyst, the first thing you draw in your mechanism is some electrons finding that acid, that H+, because H+ will jump on pi electrons and lone pairs. And in this case, it's the lone pairs on the C double bond O. This gives us our protonated acid, like this. Then we draw a resonance structure of this protonated acid where the electrons are on the oxygen and their positive charges on the carbon. And since these are resonance structures, we need to make sure we use the proper arrow, and we need to make sure we designate it properly by putting brackets around our resonance structures. So we get this protonated carbon resonance structure. We react it with the alcohol, methanol. So the lone pairs on the oxygen find this carbocation to give us this carbon that has 3 oxygens bonded to it now. If we think about where we want this reaction to go eventually, we want this OH, or one of the 2 OHs because they're equivalent, to leave. So OH is not a good leaving group, so we need to protonate the oxygen. Now, maybe the oxygen picks up a hydrogen from the environment, but it's just as easy to show it taking the hydrogen from the adjacent oxygen that has a positive charge on it. So we show that movement like this with these electrons taking this hydrogen, these electrons moving down into the oxygen. So the product will be, you'll notice now that this oxygen has 2 protons on it. It's essentially a water molecule of water. It has a positive charge on it, and it's a good leaving group, so it leaves, giving us this carbocation. Now this carbocation, I can draw a couple of resonance structures for it. The first one I'm going to draw has the electrons on the oxygen forming a double bond. More specifically, the electrons on the oxygen that has the methyl group on it. And for the second one, I'll use the pair of electrons on this oxygen to make the double bond. That would give us something like this, my 2 resonance structures. Okay, what I want you to notice is that this resonance structure right here is very, very close to our final product. In fact, all we have to do is lose 1 hydrogen to get our final product, and some base comes along and takes that hydrogen. It might be another molecule of methanol or something, but something removes that hydrogen, we get our final product. So the hydrogen leaves and we get our final product. One thing we need to remember, as I said before, this is an equilibrium reaction. So for all my steps, I have to remember that the arrow should be pointing in both directions, indicating our equilibrium, like that. And that is the mechanism of the Fischer esterification. Now there's another reaction, it's called transesterification, and its mechanism is so similar to the Fischer esterification that I want to show it to you right now. So we'll change the title because it's transesterification. And if we look at the difference in the reaction, and our reactant is different, it's an ester this time. In transesterification, we're converting from one ester to another. So my reactant is different. Also, my product is not water. This was the ethyl ester, so ethanol is my other product. So starting with one ester, going to the other ester. The only difference in the mechanism is everywhere where I see this OH right here, I have to change it to the, so I'll change it here, and then I'll change it here, then I'll change it here because we want the ethanol to be leaving this time, and I'll change it here. And at this point, once my ethanol has left, all of the other steps are the same as in this Fischer esterification. So you can see just a few changes to what we are reacting, what we start with, we can either have the Fischer esterification or the transesterification. It's basically the same mechanism.